welcome to the video lectures on compiler design. So in our previous video lecture we have seen about shift reducing parser, which is one of bottom up parser. Now we'll go for LR parsers. What are these LR parsers and what are the types of LR parsers, we'll see now. So LR parsers, I call it as LR of K parsers. Basically what is the meaning of LR of K parsers? So L means it is left to right scanning of the input, and R means rightmost derivation in reverse. Anyway, we have seen this in the concept of bottom up parsing, why it is rightmost derivation in reverse. So that is bottom up parsing itself, it goes with the rightmost derivation in reverse. So here R means that is only the rightmost derivation in reverse, and K is the number of look aheads. So how many look aheads you are taking? So for example, if I take the example of SLR parser, we'll take LR of 0, right? That means number of look aheads are 0. That means K value will be 0. Whereas if you go for CLR as well as LALR, we'll take only one look ahead. So that's why that is LR of 1 we'll find. So that's why K value is 1. So we'll see all those things actually. What is this? Why it is 0? Why it is 1? Okay, all those things we'll see. So when it is 0, how to get that look ahead then, and what is the procedure we need to follow. So all those things we'll see. So the model of LR parsing, how it will be. Anyway, first similar to like LL parsing, here you can see LR parsing program you need to write. It is, of course, it is different for each one, like SLR, CLR and LALR, and for each one you have to construct a table which is a LR parsing table. That means for each one SLR parsing table will be there, CLR separately will be there, like this LALR also, and where each consists like action and go to. So those things we'll see. And for after getting a table, you have to give an input string and check whether this string is accepted by the given grammar by using this parsing table and also with the stack. So we'll get the output like whether the given input is accepting or not. So we'll see these things step by step. Now SLR parsing, the first one we'll go. So how to go for this one, SLR parsing? How to start this one means first you need to include an augmented production, or we call it as augmented grammar. After adding that augmented production, that means for the given grammar you need to include one production. So like let us suppose if S is the start symbol, you have to include some new symbol like S dash tends to S, like this. So this is you have to include, then your grammar will become augmented grammar. So that means where you need to start exactly, that it will tell. Now after that you need to construct LR of 0 items. So what are these LR of 0 items means? You have to do some closure operation. So closure operations you have to do by using action and go to. So we'll see these action and go to. What are these action and go to functions, we'll see. And after that, after getting these LR of 0 items, and you have to construct the SLR parsing table by using this LR of 0 items. So now you have to check it out whether the grammar is LR of 0. That means checking whether is there any ambiguity. We have checked the same thing like ambiguity or not in our predictive parsing also. Like this, here also we'll check it out. And what is that procedure, we'll see here. And next we check whether the given string is accepted. That is a final one. Like for a given input string, you have to use this parsing table, and based on a stack, how to do that is also very important one. So we'll see all those things. So first we'll go for that is including, then constructing. Okay, one by one we'll see how to take. We'll take an example. So here you can see I've taken this grammar. E tends to E plus T slash T, T tends to T star F slash F, F tends to open brace E close brace slash ID. So what is the first step here? It is given include an augmented production. And one more thing you observe, is there any need to check out any left recursion and left factoring? No need to check it out. Even there is a left recursion, no need to check it out. Why? Because it's not like leftmost derivation. No, it is always rightmost derivation. So then even if it is a left recursion, it's not a problem here. So that is what the thing, like we don't want any left recursion or left factoring to do, that we have done in your predictive parsing. So first thing is, anyway, first we will write these productions like e tends to e plus t slash t means which consists two productions. Now I'll separate it first like this, t tends to t star f. If I separate, it will become like this. No, e tends to e plus t, e tends to t, t tends to t star f, t tends to f, f tends to open brace c separately, and f tends to id. So totally there are actually 6 productions. So now these 6 productions are given in a grammar. Let us suppose this grammar is G. So now what is the first statement, first step, what we need to do? What we need to do is include an augmented production, which is an augmented grammar. Now how to include that one means, first you need to write what is the start symbol. What is the start symbol here? E. So that I need to write here E, and left hand side you have to include one new symbol. I call it as E dash, which is a non-terminal. So something, let us suppose you have to take any non-terminal which is a new non-terminal tends to your start symbol, like this you need to include. That's it. This is, we call it as augmented production. Totally we call it as augmented grammar. So whatever the starting, let us suppose if you have starting symbol is A, what you need to write? E dash tends to A, like this. Whatever it may be, you have to take the start symbol on the right hand side, and left side you have to include one new non-terminal. So like this you need to add. Now total productions will be, of course previously 6, now it is total 7. So this is only the step 1, that is including the augmented production. Now the next step is construct LR of 0 items. So now for the given whatever the productions we have, we need to construct LR of 0 items. So this is a very important, and listen carefully this one. So I have taken all these productions like E dash tends to E, E tends to dot, E tends to E plus T, like this, all the productions. So now what I am doing here is I want to construct LR of 0 items. So, and I am not writing here the algorithm or some procedure. I just want to explain the procedure for to get the definitions and everything. You may refer some textbooks or some other resources. So just want to explain how the procedure will be here. Okay, so here first I need to take this one, the first grammar, all the productions, like I will take in a one box. Now I call it as I0. I call it as I0. Now what you need to do is you have to go to the right hand side of each production and keep dot at the leftmost position. So dot like this. This dot represents the scanning of the next symbol after dot. That means here after dot E is there. So that means I am ready to scan the symbol E. Here also E, I am ready to scan the symbol E. Here T, so I am ready to scan T. Here dot ID, that means I am ready to scan ID. So scanning of the symbols. So now what you need to do here is, so what is the first symbol I need to scan? Sequentially I need to proceed. So first here what is it? Dot E. So I'll write like this, and I'll write what is I'm scanning E. Okay. Now I'll write E. After scanning, what happens means the dot symbol will be shifted after the symbol. That's it. Only one symbol. That means whatever the symbol you scanned, it will move after the symbol. So previously before scanning it will be before the symbol. Now it will be after the symbol. So what happens here? E dash tends to dot E will become E dot. That's it, no? So that is the first step. And now one more thing we need to remember. After scanning you have to check it out. What is there after this dot? I mean, here after dot you may have 3 different constraints, no? So what are those 3? After dot, first thing here you have no symbol. That means no symbol you may find. Second thing, after dot you may find a terminal. Third thing, you may find non-terminal. So what you need to do in these 3 cases? So I'll write here. Here I'll write. So after dot you may find non-terminal. After dot you may find terminal. After that you may find no symbol or epsilon. So what you need to do in these three cases? So first I'll tell you for terminal. For terminal, after dot if you find terminal, no need to do anything. Okay, do nothing. For terminal, if you find terminal, do nothing. And for even if you find epsilon, that means if no symbol, do nothing. But if you find a non-terminal, what you need to do is write the productions, all the productions of that non-terminal. Write all the productions of that non-terminal. Even when you write the productions of the non-terminal, even if you get non-terminal after dot of any production, again you have to write. Anyway, I'll explain all those things. So these cases we'll find in that in my explanation. So I'll explain. So for our first example, so after that no symbol, so leave it as it is. And one more thing, you need to check it out in the grammar. I want to scan E, no, dot E. Is there any other dot E production? You can see only dot E. So here also it is dot E, no. So that also you need to check it out. Both should be written in one scanning. So that's why E scanning means you will not only get this one, you also will get this one, because both are dot E productions. That means both are scanning the symbol E. So that's why this also you need to write. What happens this one? E tends to dot E will become E dot plus T. So now you can see what is there after dot plus. Plus is a terminal or non-terminal? Terminal. So keep it as it is. Do nothing. Now 2 are over. That means this I call it as I1. Now of course I cannot take this one now. Why? Because dot E productions only. So you have to separately write for the remaining scannings. So dot E is over. Next production is scanning of dot T. So dot T here also dot T. I'll write those two here. So dot T I'm writing here. So the first one E tends to T dot. Okay, so after dot no symbol, leave it as it is. T tends to T dot star F. So after dot star means terminal, so no need to further derive. So like this, and now I call this one as I2. Now the next symbol, what has to be taken? Dot T over dot F. So dot F, I need to take what is dot F, you can see. So F, here T tends to F dot. Now I have to take only one. Why? Because here it's not dot F, it is dot open brace. So dot F will become F dot, and this it will be I3. Now what is the next one? Dot open brace. Only one is there. Here it is dot ID. So dot open brace scanning, it will become F tends to dot open brace will become open brace dot E close brace. Now you can see here what is there after dot E, which is a non-terminal. It's not terminal, it is no symbol. Like here you find non-terminal, means what you need to do, you have to write all the productions of non-terminal. So E tends to, what are the E productions from this, from original you need to write. So what is E tends to? Dot E plus T. Again E tends to, one more is there, dot T. Now if you see dot E is there, dot T is there, dot E productions you have written, dot T non-terminal. Non-terminal productions again you need to write. T is there, T tends to dot T star F, and T tends to dot F. Now you can see dot T non-terminal, T productions I have written, dot F non-terminal, F productions. So F productions dot open brace E, like this, F production dot ID over now. So like this you need to write. So I for this one, the final one is ID, the remaining ID have to scan, so it will become F tends to ID dot. So this will become I5. Now scanning of I0 is over now. So like this you need to scan for this one. After completion of I0, what you need to do? Go for I1. Next one, I1. I'll scan I1. What can be scanned in I1? So here you can see E dash tends to E dot. Is there any symbol after dot? No. So that's why leave it. And next you can see here, what is there after dot? Plus is there. So I have to scan plus. Plus E tends to E plus dot T. Is that right? So dot plus will become plus dot. Now what is there after dot? T, which is a non-terminal. Write all non-terminal productions. T tends to T star F with the dot first. T tends to star F, and of course dot T means non-terminal. T productions you need to write. Yes, already I have written. Next, F productions. F is a non-terminal. F tends to dot open brace E close brace. F tends to dot ID. Like this you need to write. So this will become, the next one is I6. So here I5 now, next is I6. So this is over. Now come to this one, E tends to T dot, over. There is no symbol after that. Here dot star is there, so I have to write this one. So star, if I scan, T tends to T star dot F. Now what is there after that? F, non-terminal. Write F productions. F tends to dot open brace E close brace. F tends to dot ID. So you can see, of course, after dot open brace is there, not a non-terminal. Here also dot ID, it's not a non-terminal. Now this is I7. Next, I1 is over, I2 is over. Scanning. I3, T tends to F dot. Is there any symbol after dot? No. Next, come to I4. So I4, what I need to scan first? So F tends to open brace dot E. So you have to scan E here. Is that right? E has to be scanned. So this will become what? F tends to open brace E dot E will become E dot close brace. What is there after dot? What is there after dot? Close brace, terminal, not a problem. And again one more dot E production is there. So that also I'll write. E tends to E dot plus T. So like this you need to scan. Is there any other dot E? No. And also one more thing you need to remember, after dot here plus, which is a terminal, so no need to further derive. So this is E, of course this is F, so this is I8. No, next one. Next, these two are over. E tends to T dot. No, next. Yeah, now here you can observe the scanning is T. E tends to T dot, it will become no. E tends to T dot, and now it will become second one. This is also T production. T tends to T dot star F. So like this, T dot, and T tends to T dot star F. Of course after dot there is no symbol here. Here after dot you have terminal, that's why no need to further derive. But if you observe this one, these two productions, okay, now if you observe, this is a one box, I need to take I9, but you can clearly observe this one is similar to I2. Is that right? You can say I2, E tends to T dot, T tends to T dot star F. Everything is similar, you have to check it out. Everything T dot star F, here also T dot star F. So everything should be same. So now can I write, instead of this one, can I write here I2? Yes, so I'll write. So now if you scan, it will go, it will be same to I2. Now the next symbol, T tends to dot F, will become what? T tends to F dot, which is similar to I3. Now what is the next one? F tends to dot open brace. If you scan, of course here F, no, here open brace, if you scan, it will become open brace dot E close brace. Open brace dot E, E means E productions, you have to write. Again E means T productions, F productions. Can I say again, you will get this one? See, so this is, if you scan T you got I2, if you scan F you got I3, if you scan open brace, definitely you will get this entire part again. If you want, you can say F tends to open brace dot E is that F tends to open brace dot E you will get here. What is dot E? Again E productions, again T productions F. So this is completely I4 when you scan open brace. So similarly, if I scan ID, so F tends to ID dot, can I say it is I5? So like this. So now this part is over. Now, so I4 is over. Next, I5 can you scan? No. Why? Because after that there is no symbol. Next, I6 you can see. What should be scanned in I6? T. So T should be scanned. It will become E tends to E plus T dot. And is there any other? One more is there. Dot T. T tends to T dot star F. Is that right? So these two you scan anyway. After dot no symbol, here dot terminal, no need to further derive. So this will become I9. Next scanning is T over F. T tends to F should be scanned. If I scan, what happens? T tends to, it will become F dot. So what is F dot? T tends to F dot, which is I3. I will write here I3. Next what you need to scan? Open brace you need to scan. If you scan open brace, what it will become? F tends to open brace dot E. E productions again, T productions and F productions again. Can I say it is similar to I4? Yes. I4 has to be taken. Next, F tends to ID. So which will become I5. So like this neatly you have to do one by one. So this feels like not a big issue. It's very simple. So the now next symbol is dot F. No, I will scan F. So it will become T tends to T star F dot. Is that right? So dot F will become F dot. So only one production. Why? Because this only dot F is only one production is there. So this will become I10. Now here you can see what you need to scan next. Open brace. If I scan open brace, we know F tends to open brace dot E. Dot E means E productions. E productions means T. Again you will get I4. So that means whenever you want to scan open brace, you will get I4. So here whenever you want to scan ID, you will get I5. So like this. And now the next thing is this one, dot close brace you need to scan. Close brace. So it will become F tends to open brace E close brace dot. That's it. Only one production. This is I11. Now the next thing you can observe here, what you need to scan, plus you need to scan what happens. E tends to E plus dot T. What is E plus dot T? T means dot T means T productions. So T productions means F productions. So can I say it is I6? You can see. So this is I6. Now you can see what next. I8 is over. Then I9. So what you need to scan in I9? This one is over. Here T tends to, what you need to write? T dot star. Star, if I scan, it will become T star dot F. Star dot F means F productions. So what is that? Can I say it is I7? You can see T star dot. So F production. So this is, I call it as I7. Now this is fine, over. I9 is over. Next I10. Yes, over. I11 over. That's it. There is no further. So like this you need to construct the LR of 0 items. So each one I0, I1, I2, all we call it as items. So this is a procedure actually in one page. So like this you can construct LR of 0 items. So every time you need to scan a symbol. So you have to write, after scanning the symbol, you have to move that symbol after the dot. So previously it is before dot, then after dot, and after dot you need to check it out. is that any non-terminal is there after that, then again you have to write all the productions from I naught only, all those non-terminal productions. If there is a terminal or if there is no symbol, no need to do anything. So like this we need to proceed until all are completed like this. So if there is any item which is repeated, you directly write without further derivation. Like here, if I take T means similar to I2, directly I have written I2. I don't want to again write this one. So like this you need to write it. So this is, we call it as construction of LR of 0 items. So this is about LR of 0 items. Now what about SLR parsing table? So we'll see in the next video lecture. Thank you.